Let's try to model how electrons are arranged around an atom, or at least around the nucleus of an atom. For an example, let's say here at the center, the red, that was the nucleus of this atom, whatever specific atom we'll be talking about. So that is the nucleus. And around it, we have the first energy level in orange. So let me put it here. We'll have the first energy level. And then the blue would be the second energy level. I think you're starting to see the picture. The green would then be the third energy level. And the red there at the outermost energy level for this specific configuration would be the fourth energy level. So you're starting to see a few things, but the first thing would be these energy levels are increasing as we move further and further away from the nucleus. So that is the very simple view of the arrangement, or sometimes called the configuration, of electrons around an atom. And this view simply states that electrons are arranged in energy levels, hence we had the first energy level, second, etc., around the nucleus of the atom or just around the atom. And this energy level, as I've mentioned, are labeled 1, 2, 3, 4, etc. And as I've mentioned, the energy level closest to the nucleus will have the lowest energy, and the levels far away from the nucleus, like the fourth energy level, will have the highest energy. So in this example, you can see these energy levels are shown in this concentric circles around the nucleus. So I want us to look at 3 or 4 atoms and see how these electrons would be arranged in these different energy levels. Let's look at lithium, which has an atomic number Z of 3. And since lithium is a neutral atom, so this is not an ion, it's just a neutral atom. What that tells us is that this lithium has the same as the number of protons in this lithium will be equals to the number of electrons. But how do we find the number of protons? This atomic number 3 also tells us the number of protons. So this lithium will in fact have 3 protons, which will be in the nucleus, and 3 electrons, because it is a neutral atom. We're not so much now interested in the protons, rather the arrangement of these electrons around the nucleus of this lithium atom, or the nucleus. Yes. So how would we arrange those 3 electrons? So we can put the first 2. So the first energy level only can hold 2 electrons. So we can put the first electron here, and then the second. So this is the first energy level. This is something you should always know, can only hold up to 2 electrons. And then the third electron will then go to the second energy level. So this is how those electrons would be arranged around the nucleus of the lithium atom. So we'll have the 2 electrons in the first energy level and the 1 electron in the second energy level. Let's now have a look at fluorine, represented with the chemical symbol F. The atomic number for fluorine is 9. This tells us that fluorine, a neutral fluorine atom, has 9 protons. Because it's neutral, it means it also has 9 electrons. So 9 protons will be in the nucleus, and the 9 electrons will be arranged the nucleus of the fluorine atom. So how will those electrons be arranged? As we did with the case of lithium, the first energy level can carry about 2 electrons. So the first electron will be there, the second electron will be there. This is the first energy level. The second energy level can hold about 8 electrons. So we need to arrange. So we have 2 can hold about 8. Have an electron there, another electron there. Let's say another one here, and another one here, up until we get to 9. And then another one will be here, and then another one might be here, and maybe the last one would be here. So if you were to count, if we were now say, let's count the number of electrons in this fluorine, we would say it's 1, 2 in the first energy level. So in the first energy level there, we have 1, 2 electrons, and then in the second energy level, the blue, we have about 1, 2, 3, 4, 5, 6, 7. 7 plus 2 will give us the 9 electrons. So that's how those electrons would be arranged for the fluorine atom. Another example we can look at is the element neon, which has an atomic number of 10, meaning it has 10 protons. It's a neutral neon. It also has 10 electrons. So because previously we arranged these electrons for the fluorine, which had 9, so it means the first 2 electrons are going to go to the first energy level. That energy level can only hold 2 electrons. The second energy level, I said, can only hold about 8 electrons. So how many electrons do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we just need to add the last electron. When we do that, we can put it here. You see that the first energy level has about 1, 2 electrons. The second energy level has about 1, 2, 3, 4, 5, 6, 7, 8 electrons. 8 plus 2 will give us the 10 electrons. So this is how the electrons of the neon atom would arrange themselves around the nucleus of this atom. Now, finally, we have neutral calcium with an atomic number of 20. Z is 20. It means it has 20 protons in its nucleus and 20 electrons arranged within that nucleus. So, because we had already arranged this for the neon, which had 10 electrons, it's just a matter of adding the remaining 10 electrons. Remember, the first energy level can hold a maximum of 2 electrons, the second 8, the third also can hold a number of them. So let's see. So we want to add how much? We want to add 10 electrons. We say, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, and the other 2 electrons will be in the 4th energy level, which is here 1, 2. We take this a bit higher so that you can see where that electron is. So now you see we have placed all the 20 electrons. So we have something like that. They don't look perfect, but I'm hoping they are able to draw you a picture of how these electrons might be arranged. So in the first energy level, we have the 2 electrons. In the second energy level, we have the 8. In the third energy level, we also have 8. And in the last energy level, we have 2. In total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 electrons arranged around this calcium atom. But in as much as I've said this, the situation is not quite so simplistic. It's slightly complicated because within these different energy levels, we also have orbitals, and these electrons move in those orbitals. When you talk about an orbital, it defines the space or the region where the electrons move. Remember, these electrons are orbiting your nucleus. So let me explain that a bit better. Remember, I said to you that within the energy levels, we have orbitals. So we have different orbitals. We have s orbitals, p orbitals, d orbitals, f orbitals. But for this video, we will only talk about the s and the p orbitals. So remember, the electrons, the energy levels were increasing from the nucleus. So that's why there on the vertical, you'll have energy which is increasing. And then let's say here you have the first main energy level. Then you have the second main energy level following the first one. Then you have the third main energy level. So how would these orbitals arrange themselves? So you, in the first main energy level, you have what we say is the s orbital, first main energy level, hence the 1, and it is the s orbital. In the second main energy orbital, you still find the s orbital, but in addition, we also find the 2p orbital or the p orbital, right? The same thing happens in the third main energy level. You have the 3s orbital, and you also find the 3p orbitals. There are also some 3d orbitals, but like I said, for this video, we are only talking about the p and the s orbitals. And then in the fourth energy level, you can also find the 4s orbitals. So you see they're increasing in energy, and within the different energy levels, you can find the different orbitals. And these orbitals carry electrons. And there are a few rules of how the electrons would essentially arrange themselves within this orbital, something we call electron configuration. And I'll show you just how they actually arrange themselves. So let's draw this energy level diagram, or something called an Aufbau energy level diagram for fluorine. We have said that fluorine has an atomic number of 9, meaning it has 9 protons. And since this is a neutral fluorine, it's not an ion of fluorine, it means it also has 9 electrons. So it means within this orbitals, we must see how those electrons are going to arrange themselves. And this is how you would typically do it. So for fluorine, we have 9 electrons that we're trying to arrange in the different orbitals. So yeah, we'll represent those electrons with arrows. The 1s orbital can only, or the s orbital can only take 2 electrons. So the first one will be spin up, the second one will be spin down. Then we are done. So we've already added 2 electrons. Now we need to see where will the 7 go. Then we go to the second s orbital, or the 2s orbital. It's an s orbital, so it can only take 2. Spin up, then spin down. So you must see that these orbitals are also increasing in energy. The 2p orbital is at a slightly higher energy than the 2s orbitals, right? But For these s orbitals, it was easy to pair these electrons up, the spin up and the spin down electron. For the 2p, the situation is slightly different. You must first add the spin up in this 2p orbital, then the next one, then the next one, right? Still remembering to count. Then you see how many electrons have we filled in. 1, 2, 3, 4, 5, 6, 7. So you need to get to 9. Then after that, you can add the spin down. And if you see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons now arranged in that way. So we would write the electron configuration. We'll say the 1s orbital has how many electrons? 1, 2. The 2s orbital has how many electrons? It is 2, 2s. The 2p orbital has how many? 2p. It has about 1, 2, 3, 4, 5. 5. So 2 plus 2 plus 5, that is 9. We can do a similar thing for the calcium. So calcium has an atomic number of 20. It means it has 20 protons. And since it's neutral calcium, the number of protons will be equals to the number of electrons. So we need to see how these 20 electrons would arrange themselves here. Still do the same thing. In the 1s orbital, you have a spin up electron, a spin down. We are left with 18 electrons. In the 2s orbital, we have the spin up, then the spin down. Here we first fill in the different p orbitals before we can then add the spin down. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you need to add 10 more electrons. In the s orbital, spin up, spin down. Then for the p, spin up, spin up, spin up. Then we come back to do the spin down, the spin down, the spin down. How many is it? So we said it's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this is how you would draw the Aufbau diagram for a neutral calcium atom. So how do we write the electron configuration? The same way we did. How many electrons in the 1s orbital? 2. How many electrons in the 2s? 2. How many in the 2p? 6. How many in the 3s? 2. How many in the 3p? 6. How many in the 4s? 2. So if we add all of this is 10, 12, 18, 20. You have about 20 electrons like that